Alright, so this question reads, find the inverse of A if A is equal to the following matrix. The first step is to find my matrix of minors. So I'm going to write capital M. And to do that, first I'm going to rewrite my matrix. I have 1, negative 2, 2, 2, negative 3, 6, 1, 1, 7. So if you have watched my previous videos, or if you just know how to do this, all I'm going to do is get rid of this row and this column, find the determinant of this, then I'm going to get rid of this column and this row, and I'm going to find the determinant of what's left over and put it in its place. I'm going to keep going, so then I find the determinant of these 4, and so on and so forth. Now, the first one is I want to find the determinant of negative 3, 6, 1, 7. Negative 3, 6, 1, 7. Next, I'm going to find the determinant of 2, 7, 6, 1. 2, 6, 1, 7. And then I find the determinant of 2 minus 3, 1, 1. 2 minus 3, 1, 1. I move on to my second row. I'm going to cross out this and cross out this. Now I'm left with negative 2, 2, 1, 7. Negative 2, 2, 1, 7. Definitely did not make my brackets big enough. I'm going to cross out this row, this column, and this row, and I'm left with 1, 2, 1, 7. 1, 2, 1, 7. And then I cross out this column, this row, 1, negative 2, 1, 1. 1, negative 2, 1, 1. Last one. Cross out this column and this row. I'm left with negative 2, 2, negative 3, 6. Negative 2, 2. Negative 3, 6. Then I have this one, so cross out this row, this column, 1, 2, 2, 6. 1, 2, 2, 6. Now I have 1, negative 2, 2, negative 3. 1, negative 2, 2, negative 3. Now I actually have to write those determinants down. So let's see. My matrix of minors is equal to 7 times negative 3, so negative 21 minus 6 times 1, which is 6. So negative 21 minus 6 is negative 27. Now 7 times 2, which is 14. 14 minus 6 is equal to 8. 2 times 1 is 2, minus negative 3. So 2 minus 3 is 5. Now I have negative 2 times 7, which is 14. 14 minus 2. Negative 14 minus 2 is negative 16. 7 minus 2 is 5. 1 minus negative 2 is 3. So negative 12 minus negative 6 is negative 6. 6 times 1 is 6. 6 minus 4 is 2. Let's see, negative 3 times 1 is negative 3 minus negative 4. So I have 1. Okay, to find my matrix of cofactors, which is next, I'm going to apply the following pattern. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Positive times negative is still negative. Negative times positive is negative, so negative 8. 5 times positive 1 is still 5. Negative 1 times negative 16 is 16. Positive 1 times 5 is still 5. Negative 1 times 3 is negative 3. Positive 1 times negative 6 is negative 6. Negative 1 times 2 is negative 2. 1 times 1 is still 1. Okay, so using this, I'm going to find the adject. In case you don't remember, to find the adject, all I do is switch these two. I switch these two and I switch these ones. So let's just do that. My adject is -27, 16, -6, -8, 5, -2, 5, -3, and 1. My last step is to multiply my adject times 1 over the determinant, but first I need to figure out what the determinant of A is. Let's write it out. So 1, -2, 2, 2, -3, 6, 1, 1, 7. I'm just going to expand this, so I'm going to take these two columns and write them out again. So 1, -2, 2, -3, 1, 1. All I'm going to do is draw some diagonal lines. It's just going to help me out. 1 times -3 times 2 is -6. 1 times 6 times 1 is 6. 7 times 2 times -2. 14 times -2 is -28. 1 times -3 times 7 is -21. 6 times -2 is -12. 2 times 2 is 4. So I'm going to add these three together and add these three together. -21 plus -12 is -33, plus 4 is -29. -6 plus 6 is 0. 0 minus 28 is -28. So -29 minus -28 is equal to 29 minus -28 is equal to -1. So I'm going to multiply my adject times 1 over -1, which is -1. And what I get is -27 times -1 is 27. -16, everything's just going to be changing signs. 6, 8, -5, 2, -5, 3, and -1. So this is my inverse.